All right, on today's lesson, we're going to be evaluating logs. And here's kind of the plan of attack. You're going to still use the swirling method that we talked about. The goal on the second step is to make the bases the same. And I would say that this is the step you're going to have to stop and think and get really comfortable with exponents and things like that. And I'll show you. So once we get the bases the same, then we just equate the exponents and we're done. So hopefully you'll see that these go pretty quickly. Now, on the first couple, you will notice I put equals x on there. You could do this on every single problem. I just did it on the first two, but this helps me know how to swirl this. So let's look at this and see how it works. If I swirl this, 6 to the x equals 36, right? Well, that's the swirl. That's step one. Number two says make the bases the same. Well, I'm going to leave 6 to the x the same. I know that 36 is 6 squared. So notice how I just rewrote it with bases the same. Once the bases are the same, the bases drop out and the exponents drop down. And you have your answer, x equals 2. Let's try another one. Number 2 says log base 2 of x is 8. So I would say 2 to the x equals 8. Then I want to rewrite this. Well, I have a hint here. On the left, 2 is pretty low. I should be able to rewrite 8 as a power of 2. So think about your powers of 2. 2 times 2 is 4, but times 2 again is 8, so that's 2 to the third. So now that my bases are the same, they drop out, exponents fall down, x equals 3. Look at number 3. Notice this one doesn't have an x, but you can definitely put it there. So this will be at 3 to the x equals 3, but isn't that 3 to the first power? Just rewrite that one so you have exponents on both. And notice my bases are the same, so the exponents drop down, and I'm done. Look at 4. 4 is a little different. It's still equal to x. If I swirl this, I'll have 3 to the x equals 1. Well, this is kind of weird, but what I want to do is the one with the x on it, I want to leave that base alone and rewrite the other side with that same base. So what power can I raise 3 to get to a 1? Hopefully remember that anything to the 0 power makes a 1. Anything to 0 power makes 1. So now I have the bases the same, and I can just drop the exponents and have x equals 0. Look at number 5. Let's see. If I swirl it, I have 9 to the x power equals 3. Now, normally the base so far has been on the right or the left side of our equation, but this time it's on the right. Notice it's go with the smaller numbers. That's usually helpful. So I'm going to say 3, and I have an x here. Now let's stop and think. 3 squared is 9, right? So if I rewrite 9 as 3 squared and just tuck that 2 beside the x in the exponent, we're good to go. And the 3 on the right is just 3 to the first power. Now my bases match, and I have 2x equals 1, and I just solve it. So x is 1/2. Number 5. It's the 125 to what power equals 5? Okay, I want to go with the smaller of my numbers here. So this is 5 to the first. Now let's rewrite 125 as a power of 5. So 5 times 5 is 25, but 25 times 5 is 125. So hopefully you'll get to where you have these memorized. So this is 5 to the third power with the x. Now the bases match, and I'll have 3x equals 1, divide by 3, so x is equal to 1/3. That's just saying the cube root of 125 is 5, and it is. All right, let's come back up here to number 7. Let's try this. All right, if I swirl it up, 16 to what power is 8? Okay, now, you can't make 8 the base because 16 is not 8 to some power. So let's think even smaller than 8. What could we do? And I'll give you a hint. You're going to go down to 2's, all right? Because I know that 8 is 2 to the third, and I know that 16 is 2 to the fourth. If you don't know that, learn that, okay? Memorize that. 2 to the third is 8. 2 to the fourth is 16. Might be good to know 2 to the fifth is always 32. Those are just good memory things to have in your head. Now that the bases are the same, they drop out, and my exponents drop down. So I have 4x equals 3. So I'm going to divide by 4. So x is just 3/4. Number 8. If If I swirl this will be 7 to what power is 1/7? Well, I think we should keep our base as 7 because I know this thing could be written as a negative exponent. So 7 to the x power is same as 7 to the -1, right? 1/7 is equal to 7 to the -1. So I'm just rewriting it as a negative exponent. Now my bases look the same. Exponents drop, and I'm done. Look at number 9. This one's a fraction. So I'm going to say 1/3 to what power is 27? Well, I think we should go with 3's here because we know how these exponents work. If I make this 3 to the -1x, then it's just a whole 3. It's no longer a fraction. I know on the right side that 27 is 3 to the 3rd power. This is another one you want to know. Now my bases look the same. So now I have -x equals 3, so x will equal -3. There it is. Number 10. 16 to what power is 1/2? Okay, this is where I'm hoping you remember that 2 to the 4th is 16. So let's make our base a 2. 2 to the 4th is 16, so I'm going to put that 4 up there with the x. This I can rewrite as 2 to the -1. Now the bases match, so the exponents fall out, and I can solve. So x is equal to -1/4. Now look at number 11. This one's in decimal form. Well, everything we've done so far is fractional, so let's put it back in fractions. Makes it so much easier to solve. So let's rewrite this as a fraction. So let's say log of 1/2 of 1/4. Now when we go to solve this, we're saying 1/2 to what power is 1/4? Well, I'm hoping that you know that 1/2 squared is 1/4. Okay, and the bases will fall out and my exponents go down. There we go. Number 12. What is my base here? Well, it's 10 to the x equals 100. So my base is 10. 100 is 10 squared. Bases drop, exponents equal, and we're done. No further solving there. Let's jump over here to number 13. Okay, we got radicals here. No worries. We're going to say 10 to what power is the square root of 10? Now I'm hoping you remember that these are these rational exponents. So 10 to the x is equal to, I can rewrite square root of 10 as 10 to the 1/2 power. I'm hoping you remember this. And then my bases match, exponents drop down, and I have x equals 1/2. 14, very, very similar. 10 to what power is the cube root of 10? Well, I can rewrite the cube root as 1/3. So 10 to the x power is 10 to the 1/3 power. Bases are the same, exponents drop down, and we're done. All right, now, before we move on, let's do just a quick commercial break, reminder of some things we discussed before. Remember how we said the other day, pi is 3.14, everybody knows that. And I introduced to you that number e, and we said it's approximately 2.72. That's just an irrational number we use. Now, we also talked about if you see log base 10 of 7, we know that that really means the log of 7, right? The base 10 is understood, so we don't write it like this anymore. And we call this one the common log. And we also talked about we don't see the log of base e anywhere. We rewrite that as the natural log of 7. So we don't ever write this, never, never, never. This is what we call the natural log. So we're going to do some natural log practice here on these as we look at the next few because they all have an e in them. So just reminding you what to do there. Now, look at number 15. All right, if I put my equals x in there, just swirl it. So I'm going to say e to what power is e? Well, hopefully you know e to the first is e, so the bases drop out, so x is 1. This one, all right, there's an e there. If I swirl it, that's saying e to the x power is e to the 3rd. Bases are the same, remember e's a number. Bases are the same, so my exponents drop out, and x is just 3. Last one. Swirl it. E to what power is the square root of e? All right, this is that rational exponent thing. This is 1/2 is the square root, right? So rewrite it as the rational exponent. Now my bases match, exponents drop down, and we're done. So the base of E makes it pretty simple. Okay, so today I hope you can do all of this without a calculator. That's the goal here. You need to remember, start learning some of these cubes and stuff like that. It would really help make this process go easier. Make sure you remember the rational exponent stuff. That's going to be really helpful to get a grasp on that. So please ask questions if you need help, and we'll see you in class.